Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 119, number of possible sets of closing branches. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. So this one is, for a hard problem, this is a little bit on the easier side, but only if you know certain literature. If you don't, then, well, I mean, it's going to be a little bit harder. But really, though, to be honest, the literature you need to know is not that big, but it just depends on how much time you spend to solve it. So the more you know, maybe the less time you do. The biggest thing to notice is that n is equal to 10. And when n is equal to 10, the first thing that comes to my mind is 2 to the 10 type things. And this even asks you, the number of possible sets. So you're talking about then the first thing you curious about is whether you can do the power set, right? And with n is equal to 10, you can do power set, which is 2 to the 10 number of sets, right? Well, or at least that's one component that can possibly be true. And then the idea is that, okay, let's say we are able to get a power set, right? So we are able to do 2 to the 10, which is about 1024, which is 1024, right? So let's say we have that. Then what is the thing we're doing, right? Then after that, it's just become a shortest path algorithm. This is a rated one, so you would maybe do Dijkstra, and Dijkstra is just, what is it? I mean, you could do it in like V square, right? So if you do V square, or pairs Dijkstra, I suppose. But yeah, and you could do that in V square if you really want. And we do all pair Dijkstra, that's gonna be V cube, which for 10 it's gonna be fast enough. Because that's just 1,000, 1024 times 1,000 is, a million, which should be good enough. Even though I know this is Leetcode, you never know. So, especially in Python, so you never know. But, worth it to at least give it a shot. And yeah, and then the other thing that you could do is Floyd-Warsaw, which is what I did. Let me put it here so you can Google it if you are not familiar. And Floyd-Warsaw. Floyd-Warsaw is a dynamic program, or pair shortest path problem that solves non-negative rates. And yeah, and really that's pretty much it. Let me go over it real quickly. I'm not going to go over how Floyd-Warsaw works because it's a little bit like you just have to learn it. It's a relatively basic shortest path algorithm. I don't know if it's useful for interviews that much. I don't think I've ever seen it on interviews necessarily, but for competitive, it does come up enough that you should learn it. But yeah, first I convert the roads to the Floyd-Warsaw's adjacency matrix. So instead of an edge list, I convert it to an adjacency matrix, and because they said that there could be roads that connect two cities. More than one road can connect more than two cities. Wait, what? More than one road can connect two cities. So we just set it up this way to always take the min because you always want the greedy anyway. And then here is our friend Bitmasks. You can do it a little bit differently if you like, but still, this is the way that we did it. Yeah, you could do it with recursion. I think technically maybe it's a little bit faster, but But yeah. And then here's the good for the Floyd-Warsaw. Given a mask, basically is saying that if the ith bit of mask, and I'm not going over bit mask in this video, apologies. But I don't use anything that complicated, so I'll just go over what I'm doing with the mask. If the ith bit of mask is true, one, then we are keeping the vertex or the node, I think. So yeah, so that's the way that I did it. I think they talk about closing and removal, but for obvious reasons, if you're closing one set, that means that you're keeping the other set, and if you're doing every possible set of the power set, then it doesn't really matter which one you keep, or then you're going over all of them anyway. So it'll be symmetric in that regards. So then here I just set up a new adjacency matrix. If we're using U and we're using V, we copy the distance. We calculate the shortest path using Floyd-Warsaw, and then now for each one that we use, we just checking that the closest thing is greater than max distance. Or if the shortest path is greater than max distance, then you return false, otherwise return true, and then just count them all. Yeah. So what's the complexity here? Well, the power set is going to be. Let's just put it here. The power set is going to be O of 2 to the n. And then for u to 2 of the n, 2 to the n, you do n cubed work, right? So this is the complexity of the time, and space, you just n square. I think that's pretty much it. And yeah, so basically, in a way, this is fairly brute force. So that's why a lot of people got it very quickly. But you have to know the literature, obviously. And you can also do all pairs Dijkstra. Yeah, if you like. But yeah, that's all I have for this one. Let me know what you think. I'm gonna show you this good code again, or the function. I'm not calling my code good, but I just mean the function good for the code for the function good. And then here's the bit mask iteration power set, and here's just the setup. That's all I have for today. That's all I have for this part. Let me know what you think, and you could watch me solve it live during the contest now. 624. No off by 1, please. N is 10. That's actually important. Okay, so you give an N max distance. Multiple roads are allowed. That's not even clear what that means. I mean, I know what they want to mean, I think, but it's like this one, but it's actually not super clear. But okay. So 10,000. I mean, just brute force, right? There's a weight as well. Two times 2,000, 10, 10, 10 is okay. Yeah, that should be actually. Yeah, okay, fine. Yeah. Okay. That's actually not even necessary. Okay, fine. Actually, what I want is. Yeah. It's a metric, right? Yep. Okay, so we want that as well. I'm kind of slow on this one. I think I know. So 572. All right, that's not great. Why? Why? Zero and 3. Should be done already. This is actually pretty bad. Would have been maybe a very good score. 0 doesn't matter. Yep. 3. Oh no, I'm keeping 1 and 2. So that means this is the ones that I'm keeping, not closing. Right? No, I mean, it should be still the same. If I'm keeping 1 and 2, that means I'm closing the other one. 0 and 3. Oh. If I have 1 left. Yeah, okay. I am dumb. 572. Alright, YOLO submit. What a silly mistake. With times I'll also be sad. What a silly mistake. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, this explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.